Well, good day, everyone, and welcome to this month's webinar. It looks like I'm falling into a pattern of monthly webinars, and I've got two more planned over the next couple of months, and you'll see those on the various ways that I advertise these things, but also on the Accendo reliability site. And I'll bring that link back up here in a few minutes or near the end of the session so you can click over to it. But there's a mailing list that I send out monthly that has not only the Accendo webinar series, but also any of the programs that I can find that provide webinars. We try to do a monthly roundup of all of those things and advertise them. The thought being that we all have things we're interested in and would like to learn, so might as well be aware of them and not miss out on some of the great material that's being offered out there. So I mentioned Accendo Reliability. It's part of the fmsreliability.com site. It's FMS Reliability. Let me add it to the chat window, fmsreliability.com. And you can find it under the link for Accendo. So diving into today's topic, and the abstract was a little bit vague, but it talked about the idea, or the concept is that oftentimes we get a lot of pushback or resistance to developing a reliability program or working on reliability activities because it's different. It's changed from what we've done before. And so I wanted to explore that a little bit and discuss with you, using the chat window and the questions and answers, ways that we can break through that cycle of just always doing the same thing before. And so the basic idea is we often know what we should be doing or where we could add a lot of value. There's a lot of tools available for us to explore and to provide input and information back to the entire team, and we get a lot of resistance for that. And there's a range of different reasons for that, of course. One of which is, I just need the plan now. We just don't have time. We just don't have the wherewithal to fight the battle and get everything done every day. So we pull out the plan that we did last time. You know, the program from 2, 3, 4, and sometimes even longer, that we did that before and it worked okay, so we'll do it again. Or even with best intentions, we meet the deadline to get the plan in place with the intention to modify it as we go. And then it becomes, again, just a time constraint. How do we find the time to actually tailor the plan and modify the plan so that it works for us? I'm not sure if anybody's run into this. I know that we're all busy, and I appreciate you taking time to join me today, but we'll explore a couple of ways to deal with this. The other bit of feedback we get is, well, it worked last time, and our current project, or the product we're working on now, is similar to the last one. So, you know, let's just use what we did last time, and it worked before, and we're doing okay, so let's use this. You know, I think, what possibly could go wrong, right? We'll monitor it as we go, we'll track it, but there's some danger in this, but it's also a strong motivation why we use the plan that we used before. And it's something to keep in mind as we explore how do we add more value, how do we add more material worth in a reliability program. And then there's the basic idea of that, well, if we make a change to something, then we'll have customers' complaints and we'll have field failures. You know, what if this idea of, say, halt testing, this newfangled testing procedure, what if it doesn't work? And we spend money and effort and resources on doing something new when we're not really sure if it's going to happen or not. There's a risk in trying something new. So there's a general hesitancy to trying it. And that's pretty normal. I've seen that a good number of times. So what else? Using the chat window here, let me pull up a little different format. Are your plans customized, or are you seeing these pushback or obstacles to how we actually go about doing a reliability program? So, what do you see drives you to use a plan that we've used previously, whether it's a test plan or a program plan? More thinking of a test plan, do you always use the same one, and if so, why? Cutting, leading, yeah, the time, yeah, lead time. Yeah, especially, I agree, Raphael, if we know we don't have to learn how to do testing a particular new program, or we don't need to put in new capital, we don't need to add education, for example, it's great, right? It saves us a lot of time. And I agree, Tim, that using a template is a great place to start, especially if you use it as a base. It's what I've seen, though, too many times is that we use it as a base and then we don't expand beyond that. Once it gets into the record, if that's what we're going to do, the rest of the program team says, all right, we'll do that. And that's a decision done, and we'll move on. Yeah, SOPs, yeah, best practices. Yeah, Gregory, it really works if it continues to evolve, right? I'm sure each of you have run into a situation where you're looking at a best practice from 10, 15 years ago, and does it really apply anymore? Materials change, customer change, all kinds of stuff change. Yeah, same family. There's a good argument there, Tim, that if it's a minor change, say a cost reduction or adding one or two features, but 90% of the product remains the same, I can see that argument, and I understand it. Do we really need to do everything again, though? What areas do we really need to focus on? How do we decide? And those kinds of issues come into play. Yeah. And hopefully you don't see this in your organization, where reliability is basically a set sequence of events. There's an FMEA, we do some testing, we do some environmental testing, and it's checked off at the end of the final design review. Yeah, John, that is especially if you're dealing with the same customer over and over, and they just provide you the same test. So the question I ask, though, is that valuable? Is that helpful to the customer, or is it helpful to you as a program team? So just doing what the customer expects is part of being in business to some extent. But how do we get something useful out of that process such that it actually achieves the objectives that the customer is looking for? All right, let me jump back to the bigger screen here. Yeah, good comments. Yeah, and lead time is probably the biggest area that we struggle with. It's just the time it takes to do this. But is there a better way? And I think you're on the call because you understand that there are better ways to do reliability projects or reliability activities such that they make a difference, they add value. And so here's what I mean by that, right? Part of our program plan, and I talked about this last month in the previous webinar, is that we set goals. Whether the customer sets them or we set them as a part of our business process, and we apportion the goals and set up a basic model of what we expect the reliability of the product to be. And then we make estimates. And that's part of this tailoring process is if we've got a previous similar product and we've got decent field data, well, let's use that data and then find better information for the new areas, whether it's from the vendor or internal testing or whatever. But it's a process of using what's available to provide feedback to the goals. And it doesn't mean that we have to do accelerated testing every single time. It doesn't mean we only can use field data or that we only use parts count prediction. I've seen examples of every one of those things. In some cases, parts count is the only way we have available to make an estimate. You know, is that good enough? You could argue whether it's useful or not, but if you only have a bill of material and no previous history, that's the best choice at the moment. So part of the overall structure is that we, in the reliability plan and in that process, we work with the team to know what the goals are, and then we provide feedback throughout the process. It's that feedback part that should be flexible to focus on areas of the highest risk using the best available data. And there's a continuum of information available. It's just a matter of, as the program progresses, that we continue to find and use the best available estimates and working with the design teams so that they understand where the highest risks are or where better information is needed. That may involve some testing. So another way we can make these things better is also back to the way we think about program plans. The basic concept is that most designers design away from failure. They try to size products and size materials, pick materials that will survive in the user, in the use cases, use environment. Part of doing FMEA and HALT is to identify those risks and make them explicit, make them visible to our design team. If we already have, say, a similar product and a long list of things that need to be improved, spending money on FMEA and HALT may not be useful at a system level. Let's focus on the areas that are just changing. But then also part of this is, what do we monitor during the design and prototype process such that we can detect, are those risks real or not? Do they manifest themselves? So part of the testing is also then modifying what do we evaluate? How do we measure it? What are we looking for? You know, if the issue is from customer feedback is a user interface needs improvement, well, running it through a HALT test isn't going to really help me to improve the software of the user interface or the structure of the user interface. We may need to instead invest in getting some beta customers in, or doing a workshop, or doing oh, now I'm drawing a blank on when you bring a handful of people in and show them different user interfaces and see what they like, get some feedback. Close as I can think of at the moment is a survey. But the idea is that our program should adjust and adapt to the risks that we're facing in a fixed set. Yeah, focus group. Thanks, Sean. A program plan that becomes set. Here's our sequence of tasks that we're going to do. It may or may not address the risks, the failure mechanisms that are threatening to cause problems for our customers. So it's identify those risks. If they're already known, that's great. Make sure that our testing and evaluation and validation type stuff are all appropriate, or the verification stuff is all appropriate. If we find new risks, then it's the same. It's look forward to adapt our plan to make sure that they work. Many of us already do this, but it's a part of making that a part of the overall structure and plan right from the start. So we're not going to surprise anybody by changing it later. It's a subtle difference, but I think it can help us to avoid a lot of the change management issues that occur. And then finally, Every single test should add value. And if you've attended a couple of my webinars, you probably have heard me say this before. Um, a few years ago, I was talking to a group that was making laptops, and I asked them if they used halt testing, and they said, "Oh yeah, we have to. It's part of the the basic structure of our product development process that we have a requirement to do halt testing on every prototype cycle." So we tend to send 2 samples down to the halt lab, and they do their thing, and we do that every time, 100%. We always do that. It's great. That's a huge investment. What do you do with the information? And he said, well, nothing really. We get this nice report back with lots of photos, and I stack them over there behind the door. I'm not sure what to do with them. All they show me is that if you put enough stress on your product, it breaks. So, yeah, so what? It doesn't help me as a design team to make a difference. So there was in that particular example, there was a disconnect between the team that was actually doing the testing, the management structure that said, thou shalt do this testing, whether that's management or your customer, and then the design team not understanding what this test was about, how did it operate. Now, the same can be true of any test. If nobody looks at it, if nobody uses it to make a decision, is it really useful, right? So part of a program plan for reliability should be coupled with how will this information be used? You know, who is the customer for this information? The tests create not just a checkbox in a final design review. It's what information will help that design review actually make a good decision. And it's connecting every single element of your reliability activities to something that actually makes a difference, that actually adds information to help a decision. And it's oftentimes where our value is found. So if we set goals and measure them and provide that feedback to the team, if we identify risks and then make sure that we can detect those risks if they occur, and then making sure that there's a connection between what we do, testing in particular, and where is that used? How is that information beneficial to the team? Those are some ways to make a better program. Now, we can also talk about reliability culture and being proactive and all kinds of other things to it, but this is the gist of what I mean by tailoring your reliability activities to your current situation. And as you know, things happen. Designs change. Material suddenly goes bad. The first prototype, it worked fine, and second prototype, it didn't. Or we finally get the molded parts, and something is not quite right. And now we're up against a time crunch of actually redesigning the mold, the long lead times involved with some components. All kinds of things are happening, but it's how we adapt the program to always provide the most value. That's a big key to what we're trying to do. So what other ways, let's back into the chat pod again, what other ways can you improve your program? I've covered a few things, but I know there are a good number of you out there have been to a few of these sessions, and I also know you've got a lot of experience. So what do you think? How can we, what would you rather do than just do the previous program, previous task? I can Yeah, Mark, one of the one of the hurdles I ran into um, was that the R&D, the pure R&D part of an organization would come up with this neat new thing, and then we'd immediately drop it into a product development process when it wasn't fully developed, it wasn't characterized. Ideally, we would know the reliability aspects of, say, a new material or a new invention before we try to commercialize it. But that overall time to market idea really drives against this. But I agree, if we can separate this new technology out and characterize it fairly well before we drop it into programs, there's a huge advantage to that and less risk to the product slipping or being slowed down. Yeah, Kirk, history, driving to failure mechanisms and root causes. Um, One of the things I've seen is teams will create um, basically a repository of what they know and don't know. What are the boundaries? Now that may be encapsulated in, say, design guidelines or uh, checklists of things to consider as you go through a program. When that's done well, it becomes really, really useful. Yeah. And Raphael, you're exactly right. Is to be proactive, we got to look ahead. We got to get ahead of ourselves. So if we're spending all of our time just cranking out a bunch of tests that may or may not be of any value, uh, we don't tend to have the time then to look forward. So part of that program is the activities that allow us to identify those risks and look forward. Uh, the unknowns part, John, that one I've used just really simple reliability models, say a block diagram, and instead of just putting a value or a failure rate or something like that in each one, is put the amount of uncertainty in the quality of the prediction or the quality of the estimate. So for things that are just strictly engineering judgment, there's a significant amount of unknowns there. Or if we had some literature on a similar material but not exactly what we needed, there's more uncertainty there. So adding the variance term basically, or the I hate to say confidence because it's not really that, but it's the uncertainty element, a measure of the uncertainty, is a great way to help target that. And we all know about all the red flags. It's a new vendor, it's a new material, it's a new production facility, it's a new interaction, it's a new combination of materials. Mostly anything new gets a lot of attention. It's also how do those new things interact with the existing things. It's an area that we often have to step back for a second and say, how does the bigger picture also work? Is there enough change that it's going to impact us? All right, great. Good ideas, everybody. All right, so if we know that there are better ways, and we know we've got time pressure and budget pressure and things like that, but what are the obstacles? I've talked about this one a couple of times. It's just, as a reliability engineer, you may be supporting multiple teams, multiple programs being developed, or it's a very large project with, say, 5 or 6 different design groups working on different parts of your system, and you're supporting all those. It's like having 5 projects all at once, plus the overall project. That's a lot of work for anyone. So time is a big obstacle. I'm not asking you to work 100 hours a week. It gets back to that notion of, well, how do I set the stage so that we have the time to focus on what needs to be done? And where do we find that time? So we'll come back to that in a moment. Another real obstacle, and this one is often a long lead time type of project. Let's say you're trying to bring halt testing into your organization. We use that as an example that many of you have probably gone through this process. You finally convince a couple decision makers that finding failures earlier is worth the effort. And then they look at the price tag for a halt chamber, and we need a special room, we need the nitrogen, we got I don't know how many different buildings I've seen that have the doors cut out above them because the halt chambers are larger than the existing doorway. So there's all kinds of things that go on to install a test facility that has a halt chamber in it, for example. And that's beyond normal budget cycle. It's not an expense. And so it might be $50,000 or $150,000, depending on your particular circumstance. And that may take a year or more to put into the budget and to plan for and get approved. Now, some organizations that have a little bit more flexibility there, but very few can quickly just turn on a dime and buy a $100,000 piece of equipment. So that's a real problem, but what do? If you don't have the budget for the hardware to do the testing, what are your options, right? How do we go about solving this problem? So there's a short-term problem and a long-term problem. We'll come back to this in a moment. But there's also that risk. Program managers, the folks that coordinate bringing a product to market, are by and large risk takers because they're willing to make decisions on scant information. But they also have that very real risk of they don't want the product to fail. And by managing what risks we take and using things that we already know about, say the environmental test suite of things that we did last time, it reduces the amount of unknowns they have to deal with and focus on. Well, that may or may not be the right risk to be addressing. So how do we accommodate the risk of doing something new, say the first time we do halt testing, versus the risk of product failures? And how do you balance those two things? That's a real obstacle to how we move forward with our programs. And sometimes it's just change, right? It's just we're going to do something different, and that's a red flag. That's something new. Will it work? Will it not work? I'm not sure how to deal with that. I don't know how to address that. I'm not sure I fully understand it. And the folks that we're working with also don't have time. They're not going to go spend a week in training, by and large, to address this thing. So change and change management, independent of what it is often a difficult aspect of working in an organization. So how do we overcome this stuff? What are some of the ideas to overcome this? Well, before I get into ideas, what other obstacles do you see? What other ways will thwart our ability to do a good job as a reliability professional? Yeah, Kirk, exactly. Sometimes we can get a number and sometimes we get what fails. And is the test suited for the question we're trying to answer? That's exactly right. But what else? I talked about time and budget, and that just change itself is bad. Also the risk of the unknown. What else? What are some of the other things that we see as obstacles to implementing a good, proactive, useful reliability program? Yeah, Gregory, you're exactly right. It's not like reliability engineers are some arcane art that nobody understands. I think part of it is just that there's so many ways our products can fail, right? We get supply chain issues, we get manufacturing and transport issues, we get latent damage, we get unknown variables in the customer's use profile and how they use the product or what they expect, and then we get just normal wear out. But a whole slew of things can happen, and it's a lot of information. And that's what we bring to the table, is usually that experience of the ability to look for where the failures are going to occur. Yeah, and so the idea of all of this knowledge, and how do you bring it forward so that it's useful to the team? Yeah, management teams. It's one of the things I've run into a good number of times is the management team doesn't want to talk about failure because that's bad, and so it's just avoided. We're not going to talk about failure mechanisms, and it'll be all right. We want a good product. We want a positive spin on this. That's a real obstacle, and somewhat it takes some education. Some of it is talking in the language of management, which is money. Yeah, dirty laundry. Yeah, exactly, Kirk. Yeah, time, definitely. So, yeah, keep testing till it's good. If only we had the luxury of doing that, right? One of them I've run into is that, well, it's just a prototype. It doesn't represent our real product. Well, what else are you going to use, right? Do we want to build all the Wayne Nelson years ago, I asked him, so how do you design the perfect accelerated test? One that really answers the question, how long will this product last? And he goes, oh, that's easy. Create all of your products, ship them out to all of your customers, and just track how long it takes before they fail. And then you have all the information you need to design a good accelerated test. And even then it'll have some error because it's just a sample. But in order to design a really good reliability program, oftentimes we need to know what all of the failure mechanisms are, all of the risks are, all of the use cases are, so on. We just don't have that. So there's an inherent uncertainty about what we're doing. It's not any different than a program that's designed in a circuit board, for example. Will it work in all of the circumstances? And they go to great lengths to make sure that it's a robust design. Part of what we do is help that process. But it's a guess. Is it the right function? Is it the right performance? Is it fast enough? All those kinds of things. So part of it is, how do we get past all of these different obstacles such that we can actually make a contribution back to the organization that makes sense? Yeah, the customer will never use it this way. Yeah, there's like, famous last words kinds of things. If I only have 10 prototypes and I have one failure, very, very basically, it means that we have about a 10% problem. Now, of course, there's a lot of uncertainty in that. Yet, if we ignore that one problem, we are taking a real risk. On the other hand, if our testing was only capable of detecting a 10% field problem, 10% problem, 10% of all of our products have this issue, and the test could only detect it at that level, not lower, what are we leaving on the table? Issues that affect only 5% of the products? Is that acceptable or not? Is our testing sensitive enough to go after what we're looking for? And then there's budget and cost and time and all of those other things that go on around this thing. So I'm not going to suggest that I have a perfect solution for all of these obstacles, but here's a couple of things to think about. Time. Ideally, we would have adequate time to think through the program. What are our risks? What's our goals? How are we going to measure it? What's uncertain? What are the right techniques, whether it's accelerated testing or field data analysis? Time to gather that data and analyze it. Time to tailor our environmental testing so that it detects in a more sensitive way the risks that we anticipate. We almost never have enough time to do everything. So my recommendation is take one step at a time, right? If I can only change the analytics that we use to detect intermittent failures on an environmental testing, let's try that. Let's get the go-ahead and argue for the value of halt testing, that it helps us find failures sooner that allows the team a longer period of time to solve them, we use time itself as the argument to do something different. If I'm able to provide feedback to the program that says we're on target on our goals earlier and more often, we can adjust the material sets we use, the design we use, especially on high risk, long lead time components. So if I'm looking at in a program where time is scarce to the program, not to us, we're almost never going to have enough time. If I focus on those things that help the team achieve their time to market or achieve the milestones and reduce the risk of delaying the program, then I'm using time to create the motivation to do a change, to use different tools, to try something different. I think it's an Einstein quote that has something to do, if you keep doing the same thing over and over again and expect different results, it had something to do with insanity. I tried that once with a program manager. He didn't really like being called insane, so I don't recommend that approach. But if you find what's important to them, to the people that are the biggest resistors to the proposals you're making, and if time is important to them, then things, I use HALT again as an example. If I can say, you will have more time to solve problems if you know about them sooner, that's a decent argument to say, we got to try something different. But take it one step at a time and then build on it. That's really my main message here. If you yourself just don't have time, right? Yeah, customer will never see this, except when it stops working. I've seen that a good number of times. Yeah. And another idea is on budget. Nobody likes spending, say, $100,000 on a piece of test equipment, right? It's a direct expense, and especially if it wasn't anticipated, it's too late and we don't have the budget for it, so we can't do it. Yet, I use HALT as the example again. Let's say we really do need to identify the failure mechanisms that are likely to occur in our product, and HALT is the perfect test for it. Well, let's not spend $100,000. Let's go to a HALT lab and rent the equipment. It might cost us $10,000, which may be under the threshold of being possible. Justifying a major capital expense and a major addition to your testing facility may be a long-term solution, but to build the case to do that, oftentimes, is use rented equipment or use whatever method you can. Maybe run HALT even on a bench top. You might not be able to. I saw one team, their product created a lot of heat and had fans blowing hot air out of the back of the thing. So instead of creating an environmental chamber, they put 3 or 4 of these chunks of equipment into a closet and closed the door, and the room heated up. And so they were able to get a reasonable thermal chamber, not the most controlled environment, but it stabilized at about 80 degrees C. It was a pretty hot little room. And they used their own equipment to create the heat. It was a creative solution to a capital project problem of finding money and space to install a chamber. Once they found that jerry-rig setup actually provided them some real information that they could use, then they said, oh, this makes sense. And that was a solid argument then to do the capital budget and get it in the program and build a test facility later. So part of the especially big budget items is that you have to, it's a chicken and egg kind of an issue. You got to show that it's worth doing, it's worth the investment. So rental equipment, test labs, being creative in how you create the test conditions, and then document what works, why it was successful, how it made a difference, how it helped you find unique failure mechanisms, how it saved you time, how it lowered the risk. It goes back to that concept of value. But write those things down, right? create a value statement saying, we took this risk. We put these boxes in a closet, ran the temperature up, and we found these 5 different failure mechanisms, or we were able to estimate its life. It was a basic accelerated life test, and so on. And that led to us fill in the blank of what the value is. But that then starts to build that case that change isn't always bad, right? We actually made a difference. Yeah, Kirk, I was wondering when you were going to chime in with it's, run it out to the limits. But you're exactly right. And you've seen in some of the other comments is that, well, of course it failed, or the customer will never see this, or it's not relevant. It's that knowledge, that set of changes that oftentimes has to be justified first and proven out. And so the idea with budget is to try it at the lowest cost way you can think of, and then build it step by step in a set of arguments that says this is of value and it justifies, say, a capital expense. The other part that we deal with is just risk. One was the risk of unknowns, or will it work? Those kinds of ideas. Everything we do has risk, right? So the notion of developing a program or a project that has no risk whatsoever, I don't think anybody's going to argue that that's true. So the program plan makes decisions every day. Part of our role is to help them identify where those risks are. So tools like FMEA and HALT and hazards analysis, some of which we do anyway, but it's a matter then of converting that into action. So as one of the things is, if I'm going to do an FMEA, one of the outcomes is supposed to be a set of action items. Now, one of the sets that consider as you come out of the FMEA is, how do I alter or modify the testing that I'm planning on doing? What are the environmental factors that have the highest risk when we think through how our product's going to be used? And then, do I have enough information about customer temperature ranges or humidity ranges or vibration levels? Do I have the use information adequate to help design the testing? And then in the testing, am I measuring the right things? If there's a risk for some function to, say, a button to jam, and I'm in a vibration testing, how do I measure the pressure needed to activate that button? And that might take some creativity to link measuring the risks of whether they occur or not, or in the range of different kinds of testing we do. The other part of this risk is, well, what if it doesn't work? What if this newfangled idea doesn't provide us any information? Well, I've learned the hard way that you don't use the argument of, well, basically calling everybody insane for doing the previous thing. One of the things that occurs in programs is that, and I saw this on a consumer product where they were running new designs out every year for the holiday market. And then they would do, it was about a 6-month program, and then the alternate 6 months was a combination of idea generation for the next Christmas market, holiday market, and cost reduction of the previous one, or variations of the previous one. And so they had a very tight time to market issue. So they would literally take the test cases, the entire suite of testing from a previous product, and these were game controllers, and modify them only so they applied to the current product. And some were, almost all of them had a Wi-Fi or a Bluetooth type connection. And so there'd be a whole suite of tests just on that. But every program did it. And then at the end of the program, they had to create an ongoing reliability test. So the test engineering team just was out of time. And they're getting ready to ramp this product. Everything's critical. And so they would take the program, the product development qualification set of plans and just say, we'll just do that every month in production. And they were spending literally hundreds and hundreds of thousands of dollars every month to re-verify that their product worked, independent of what risks were there. And if that's a case where you're seeing the same test run and it always passes, or there's very little information that comes from that, is what I did is I just plotted that. I said, here's, $1.5 million worth of product testing over the last 3 years, and here's what we learned from it. Nothing. No failures, nothing useful, no feedback to the team, nothing, right? And then I used the concept of capability indexes, saying, well, here's our specification, and we're so tight and within those specifications that it's very unlikely it will ever fail. So at that point, then I just said, why are we doing this testing? And if we could save $1 million and invest that into something that was more useful and provide better information back to the team, for example, would that be better? And at that point, most people didn't have a good comeback to that other than that it was new and we don't like change. So then it goes back to that concept of take it one step at a time, right? Take one program on at a time or one project at a time. Start to build that credibility that altering the reliability program such that it adds value in every program is a good thing. And that there's not a fixed schedule, there's not a sequence that always works. But that as we approach a development program, we look to the reliability professionals to guide us to always get the best information, the best available content so that we can make good decisions. So I think that's the basic idea. Just in summary, it's one of the risks that we need to address is what happens if we don't change? What if we just keep doing the same thing, right? What if nobody pays attention to the test results? What could go wrong, right? This might be already available to you in call centers and in field returns. So what can we do different? Many of us already know there's other ways to approach development and working with design teams and identifying risks and product testing and evaluation of what we do. We have a pretty good sense of what needs to be done, but the trick is to help the rest of our team accept that. So it might be training, it might be awareness and identification of knowledge. A lot of it, though, is based on building our credibility. Part of it then is, well, what's the value of the change? What if we actually did a test that found failures earlier in our program, right? What's the value of that? It's reducing the risk of delaying the program, for example. What's that worth to the program? One idea is to quantify what's a day of lost sales. Let's say you're a consumer product. If you delay a week, that means we're not on the shelf for a week. What's the expected impact to markets and sales? Part of our role as reliability professionals, and many professions face this, is how do we manage change? Right? How do we quantify what the rest of our team doesn't know and we are only estimating? Let's say we want to do a test to find failures. If the team doesn't understand why they would want to know how a product fails, then it's a change management. We're dealing with people, and sometimes it's build an example or point to previous successes or say do the what if type scenarios. Almost all the time it takes a combination of management support, a motivation to change, and in some cases a previous past failure. So I know that, Kirk, you've written about the GM experience and their big recalls and the ignition key problem in particular. And it was one of those things that now they get it. Now they're hiring reliability professionals as fast as they can. They've redesigned their development program to really focus on quality and reliability testing and evaluation. Sometimes it takes a disaster for the organization to recognize they should have been paying attention. That's the hard way to do it. I don't recommend it. If that does occur, it might be the opportunity you need to make some fundamental changes. And then a key part is document your successes. What worked and what didn't work. And on a regular basis, let the rest of your team know that, hey, look, you guys, gave me a couple of prototypes the last cycle, and we learned these 5 things that saved us X amount of field failures. And that saved us, so many tens of thousands of dollars. And this coming program, it looks like you got a lot of new material or content and inventions in there. Let's use the same process to identify failures earlier. Does that make sense? Which is different than just saying, oh, we did HALT last time, let's do it again. Let's build a foundation, building on successes and things that work, and then over time, it becomes a natural process of picking the most successful things. And that's the underlying idea of this whole thing. So one last thought here, and then looking for any questions or comments here about this idea of how do we get away from just doing it always the same way. And I'm going to bring up the, I think it's on the links tab here someplace. I think it's on this slide. I changed the location of the chat window in case you lost it. It's over on the left now. Q&A tab's there. Oh, here it is. Links tab is down on the right-hand side of your screen probably, and the bottom of that is Join Accendo. That goes to a site that once you register with the site, it'll take you to a link for a copy of the Finding Value ebook. There's also that's where I'm keeping the recordings of the webinars. There's a calendar up there. There's a couple other features up there. And it's still in a building stage, so keep in mind that the site is still evolving, and as major changes occur, I'll let you know about it. But what do you think? What works for you to break this cycle of always doing the past thing? How do you help a team make change? I'll go back to the summary here I got. See a couple people typing that it's something that we should always be thinking about. It's not just the tools and techniques that we use and the capital we have and so on. It's how do we actually help the team make better decisions? And if what we've done in the past is not good enough because our products aren't performing as well as we expect them to, what do we need to do different? And that should be a pretty natural thing for us to go after. Yeah, Kirk, I think we've been chatting about this also, and one of the things we've just posted up, by the way, for Kirk, we interviewed him in a program on the Accendo site called Dare to Know, and Kirk talked about this concept of a lot of the information we really need is protected, either by trade secret or by fear to a large extent. And one of the exceptions recently was the key issue with GM ignition's key. And that's been a rare case when we had a lot of information presented publicly in the thought process and decision making that went into why that problem was still occurred in cars. But there is literature on some materials, some components, some types of items, generally academic and generally early in the development of those basic technologies. It's once it gets put into a program or a product that we lose access to the good information. a lot of us do a lot of good testing and are, by organizational policy, prohibited from sharing that information. You know, and I know I'm guilty of going to a conference and sitting down with my peers and saying, all right, we can't tell anybody that where we got this information, but here's what I learned last week. And what did you learn? That might help me. And by developing that network, I was able to expand what I knew and was aware of. It was always, though, below board, right? We had to keep it general. We had to keep it safe so that we didn't have any breach of contract or breaking of the non-disclosure agreements, things like that. Yeah, Mark, you're exactly right. I phrase it as is talk in the language of management. That's the big gist of the finding value work is if we can quantify it into dollars. It might be warranty, it might be cost of unreliability, it might be some other way, but it generally put it in money and make it comparable to the way we make the other decisions in a program. Yeah, continuous improvement and change often requires that management approval. It's a matter of then how do we build that? What's important to them? Is it money? Is it time? Is it minimizing risk? And then as we make those arguments is then if we address the areas of importance to the management team, it helps us to get that buy-in and to that support. Then we got to go do it, right? We got to actually make it useful and help the team actually make a better product. Building on that success then makes it a lot easier to get additional senior management support. So hopefully this gave you a couple of ideas. I hope some of it was very familiar to you and you already knew kind of where I was going with this. It is easy to just do what we did before. There's a lot of momentum in many programs to always do the same thing because it worked before, or new is bad and we want to minimize those things, or it's a customer requirement, or whatever it is. The basic idea, though, is that if we stop thinking about what we're doing and how and why it actually is useful, then what role are we playing? You know, as reliability professionals, part of our job is to enable the rest of the team to make good decisions. So it's our thought process of how to do that and apply the best available tools to help the rest of the team is what really makes the difference.